in this video, let's discuss how to solve the ambiguous grammar problem in compiler design. So if you see, if you want to call a grammar as a ambiguous grammar means it must satisfy one condition. That is, a grammar is said to be ambiguous if it is having more than one parse tree. So here we are having two problems. If you solve these two problems completely, you will be ready enough to solve any problem related to ambiguous grammar in compiler design. So it is same as the theory of computation itself. So in these two problems, if you are successful enough to draw more than one parse tree, that is, if you are successful enough to draw two different parse tree with the two different string means, then you can call these grammars as the ambiguous grammar. So let's discuss one by one. Let me take the first one. So E producing E plus E, and this E is only producing E star E. E producing E star E and E producing ID. Since the left hand side is equal of this all three projection, so it can be simply wrote in this single line. So E producing E plus E slash means this is the separator of the two different projections. So this is the different projection E star E, which is produced by the same producer E, and E producing ID is the third projection. So using these three projections, let us try to build more than two parse tree. So first I will be considering this one, E producing E plus E. Next, E producing E star E. So you remember one thing, you can only expand the tree using the capital letters. You can't use the operators to expand the tree, you can just use the capital letters to expand the tree. Now E producing E star E, you can use this E to expand the tree or this E. So let me use this E. So it will be E star E. Next, third one is E producing ID. Wherever in the leaf nodes E is there, you will be substituting it with the ID. So here E is there, I will write ID. Here E is there, I will write ID. And here E is there, I will write ID. Now travel the leaf nodes. So leaf nodes means which are not having any child further. ID plus ID star ID. So what is my first string? ID plus ID star ID. Now let's use these three projection itself and try to build another tree. So in the first tree I used E giving rise to E plus E as the first projection. Now I will use E producing E star E. So E producing E star E. So while representing the different parse tree, in which E you branched, use that one only. So this one is over, I will be using E give rise to E plus E. So I will branch for the same E where I branched in the first tree. So E plus E. Next, E producing ID. So ID, ID, ID. Now from left hand side towards the right hand side, travel with the leaf nodes. ID star ID plus ID. So what is that? ID star ID plus ID. If you compare both these strings, ID plus ID star ID, ID star ID plus ID, both of them are different. So you can tell that the given grammar is a ambiguous. Therefore you can tell the grammar is a ambiguous grammar. Ambiguous grammar. So let's solve the another question. You will get the understanding much easier. Now in the second question, who is the producer? S. So S is producing A, S, B, S. Next, S is only producing B, S, A, S. B, S, A, S. Next, S is producing epsilon. So left hand side is same. So you can write in the single line itself using the bars to separate the two projection produced by the same producer. Now I will be using the first one. S producing A, S, B, S. A, S, B, S. Earlier only I said you can only expand the tree using the capital letters, not using the small letters or the operators. Operators means plus, minus, division and all. Now you can use this S or this S to expand the tree. Next projection is S producing BSAS. So I will use this S, B, S, A, S. Now S producing epsilon. Wherever capital letter S is in the leaf node, that is where it is not having any further child, replace it with epsilon. So epsilon, epsilon, epsilon. Travel from left hand side towards the right hand side using all the leaf nodes. A, epsilon, B, B, epsilon, A, epsilon. So A, epsilon, B, B, epsilon, A, epsilon. This is the first string of this tree. Now let's try to build another one tree. So in the first tree I used this projection first. Now I will use this projection first. S producing B, S, A, S. You can only expand the capital letters. So in the previous parsing diagram I used this S to expand the tree. Here also I will use the same position S to expand the tree. So S producing AS, BS. A, S, B, S. Next S producing epsilon. Wherever S is in the leaf node, write epsilon to it. Now travel from left hand side to right hand side using all the leaf nodes. B, epsilon, A, epsilon, B, epsilon. So write that one. B, epsilon, A, epsilon, B, epsilon. Now you compare both these strings are different. So you can tell that we are successful enough to draw the two parse tree, that is more than one parse tree, which you can call this given grammar as a ambiguous grammar. So the grammar is ambiguous grammar, or you can write it as the grammar which is given here is ambiguous. So hope you understood the concept how to solve the ambiguous grammar problem in the compiler design. If you have any doubt, please comment below. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.